Okay, now we proceed with the Kruskal-Wallis test or H test. Okay, just to do some revision. Previously in the parametric test, when we comparing 3 or more mean, we use ANOVA. If you remember that, we use ANOVA technique, ANOVA method, where you have the table of ANOVA, and then we do the hypothesis testing, and the critical value is referring to the F test. But now for the non-parametric case, we use Kruskal-Wallis test to test for more than 2 population. Okay, one population we use sign test. For 2 population we use Mann-Whitney test, and now for more than 2 population we use Kruskal-Wallis test. Okay, so the step involved in the step involved for this Kruskal-Wallis test is for sure we have ranking here. So the first step is you have to arrange the data into the ascending order. Rank the data, arrange the data into ascending order from the lowest to highest, and we put the rank to the data accordingly, and then we find the sum of the rank for each group. Each group because this test is test for more than 2 population, isn't it? But we usually don't have population, so that we will have more than for example more than 2 sample, or we have more than 2 group, then that one is can be referred as the condition to use Kruskal-Wallis test. And then substitute into the formula of test statistic here. So the test statistic here, the symbol H here, N is the capital N is the total number of your data. Okay, R here is the sum of rank. The subscript here 1, 2, and K here is the how many group or how many sample do you have. Okay, we sum the rank for each group or each sample. So here is R1 square, R2 square, up to RK square. Okay, and small n is the sample size for each group, okay, or each sample. Okay, minus with 3 and multiply with the capital N plus 1. Okay, so for this Kruskal-Wallis test, the test statistic, the symbol for test statistic is H. But we are referring to table G, that the table of chi-square distribution. The symbol of chi-square is here. Just an x, okay, x square. Okay, so for this critical value, we only have one condition, which is the rejection region on your right side. Okay, remember that we have found the same case in table F for ANOVA, where the rejection region is only on the right side of the distribution. Okay, so the left column here is the degree of freedom, and this one, all of this value of the significant value of alpha. Okay, so for example, a researcher tests 3 different brands of breakfast drink to see how many milli equivalent of potassium per quart each contain. Okay, so we have brand A, brand B, and brand C. For each brand, we have 5 samples here. So N1 is 5, N2 is 5, and N3 is also 5. The sample size can be different from one group to another. It depends on the question or the situation. Okay, at alpha 0.05, is there enough evidence to reject the hypothesis that all brands contain the same amount of potassium? Okay, the keyword here is same. Okay, so now, when you are doing your hypothesis testing, okay, this is the 5 major steps. The hypothesis statement, the keyword is same. Same means no different. So there is no different. And H1 there is different in the amount. Okay, this is the standard statement for Kruskal-Wallis. Okay, similar to Mann-Whitney test. Okay, we have a standard hypothesis statement. So different in H1, no different in H9. Then referring to this data, you have to arrange the data into ascending order, which means from the lowest value here is 3.2 come from brand A, and then followed by 4.7 from brand A, up to the maximum value here is 8.2, that is from brand C. So here, for the first column, okay, is the rank. Okay, the data, okay, the rank from the lowest to the highest. And then for the second row here is the group from where this value comes from. Okay, so 3.2 just now is come from brand A, group A. Just write down as an A. The same goes to 4.7. So if let's say 8.2 is come from brand C, then we put C here. Okay, and then we give the rank for this sequence, okay, from 1 up to the maximum is 15 for this case. Alright, then by using the formula, it says that you have to sum the rank for each group. Okay, so here for group A, the rank is 1 plus 2 plus 3 plus 4 plus 5. It is 15. For group B, you look at group B, 6 plus 9 plus 11, 13 and 14, 53. And the same goes to C. Then you you substitute into the formula of test statistic of H here, and you will get the value of 9.38. Then for the critical value, okay, for the critical value, we will refer to table G, the chi-square distribution table just now. Okay, the symbol here is x square or chi-square. Okay, so the chi-square here, alpha, comma with k minus 1. K minus 1 is the degree of freedom. K is the number of groups. In this case, we have A, B, C. We have 3 groups. So 3 minus 1 is 2. Okay? And then for the alpha is 0.05 for this case. With alpha 0.05 and the degree of freedom is k minus 1 is 2. 0.05 is 5.991 here. 5.991. So we put the value to the critical value here. Okay, put in the critical line in the diagram, 5.991, and then you compare this calculated value 9.38 compared to this critical line, it falls into the rejection region. Then we reject H null. When you reject H null means you close your H null. Then you look at the symbol of your H1. H1 is different. Okay, that is for Kruskal-Wallis test. And this is the for you to do on your own, exercise 8.3.